Today we're going to review sections 1 through 4 of Chapter 2, and that's what will be covered on the quiz or the test tomorrow. The first thing you should know is what the 4 different types of slopes look like. So we have positive slopes, negative slopes. Those can be very steep or not so steep, but we have positive, negative. We have a zero slope and an undefined slope. So you should know what those 4 types of slopes look like and be able to draw a graph that meets those criteria. So if I ask you to draw a positive sloping graph, the positive sloping goes up as we read across the page from left to right. A negative sloping graph would go down as we read across the page. What kind of a line has zero slope? A horizontal line. Which means that an undefined is a vertical line. Students always get those ones mixed up, so be very careful with those. A slope of 0 is a slope, if we think about rise over run, it's one that's not rising, okay? Because 0 over something is what would make a 0, so it's not rising at all. So a slope of 0 is a flat line, whereas an undefined slope would be something over 0. That's what gives us an undefined, is when we have a number divided by 0. So if we think of rise over run, this is a line that's not running. Okay, it's just rising. Questions on those? Then the first problems on your sheet ask you to graph the relation and decide whether or not the relation is a function. A relation is a set of points. So what we want to do is graph our chart of values as ordered pairs. So 0, 1 goes together. X is our over. Y is our up and down. So over 0, up 1, create a point there. Over 1, up 2. Over 2, up 3. Over negative 1, up 0. And back to up 1. No matter how nicely they line up, do not connect the dots. We don't have an equation here, so we don't know what output we would get if we would put an input of, say, a half. Okay? So we don't want to assume that any sort of pattern is being formed when in reality something crazy could be happening between 0 and 1. Okay? So when all you have is a list of points, we don't want to connect the dots on it. We want that to just be a set of points. Questions on how to graph it. It says, then decide whether or not this is a function. There was a visual test that we had to be able to tell whether this was a function or not. What was that visual test? The vertical line test. So the vertical line test says, if we can draw a vertical line somewhere and hit more than 1 point, it is not a function. So everywhere I could draw a vertical line here, I'm only hitting 1 point, so that means this is a function. Each input gives only one possible output. So we talked about the vending machine example. And if I type in a code, I want to know what I'm getting out of that vending machine. I don't want it to be a mystery. Okay? So when I put something in, I want to know what's coming out. Each input has just one output. Questions? Go ahead and try this one. Okay, so I begin by plotting the points. We have a point at 3, 3, 4, 4, 5, 5, 3, 6, 0, 0, and negative 1, negative 1. And again, we don't want to connect the dots here at all and assume any patterns between these points, no matter how nicely they look like they're fitting together. Then we need to determine if this is a function or not. Is this a function or not? It is not a function. Why not?
Because the vertical line test failed.
It fails the vertical line test when x is 3. So if I put an input of 3 into this, I don't know whether it's giving me out of 3 or whether it's giving me out of 6. So that is not a function then. It fails the vertical line test at x is 3. Questions? Right, the next part asks us to evaluate a function at a given value of x. You had some questions similar to this on the first chapter test actually with evaluating functions, plugging in numbers for variables. The difference here is this function notation. This f of x notation is something that maybe you hadn't seen before this chapter. What that means is I have some equation that I'm naming f, and my input is called x. I want to input a -3 into this. So I'm going to replace all of the x's with -3s. That f parentheses -3 is not a multiplication. It's telling me my equation called f, I plugged a -3 into it. Okay. We do our arithmetic on the other side and we get 0. And that's it. That's the final answer. This notation is nice because it tells us both input and output. As opposed to when we just have y equals equations and we plug in stuff, then at the end we just get an answer like y equals 0. And we don't know when y equals 0. This tells us specifically we get 0 when we plug in a -3. So it tells us both parts of the puzzle.
So do you have to write f of -3? You can't write fx, f of x?
Now we want to say f of -3 because f of x is the general function.
Okay.
F of -3 is the specific solution. Other questions on function notation? All right, so when we apply plugging in a number here, we also need to apply our order of operations. That's always the way that we must do arithmetic, not just specifically if it says so, but that's just the way numbers work. So they always follow this order of operations. Order of operations says that we have to start inside of parentheses. We don't technically have parentheses here, but those absolute values kind of act like parentheses. They do not turn it into a 5 plus 2. Okay, a lot of students want to do that and say absolute values make everything positive. We have to actually do what's inside first and then work our way out to applying the absolute value. So doing what's inside there, I get a 3. Another common mistake that students will make on this problem is remembering from the last chapter that when we solved absolute value equations, we got 2 solutions. But that's when our x was inside of there and we were trying to figure out what x is. In this problem, you're told what x is. X is 5 right now. Okay? So we're not going to get 2 solutions here. We're just going to get 1 solution. The absolute value of 3 is just 3. And that's our solution. Okay. We get 2 solutions when we're trying to figure out what x is. There's 2 things that x could be. But here, we know what x is 5. And we're trying to figure out what we get out when we plug in a 5. Okay. Questions? All right, one more of this type. We're going to plug a 3 in. Oops. Following our order of operations, we work inside of parentheses, but there's nothing to do in the parentheses. So then we do exponents. 3 squared is 9. Then we multiply and divide. 3 times 3 is 9. And then we add and subtract. On the left-hand side, that f of whatever negative number just keeps on following down, and at the end you do not divide by it, because those parentheses don't mean multiplication here. It's showing what our input was. Okay? Questions?
Is there a way to check it? Like, see if the answer's wrong, or is it just...
Not really.
No.
If we're solving for an x, we can always check by plugging it back in. But being given the x, we can't really check what we get for y. So our next problems are about graphing. We had a couple different forms of graphing. This problem is given to us in slope-intercept form. So slope-intercept form is y equals mx plus b. What does the b represent?
Or
In this problem, it's a -1, and what does it represent graphically? The y-intercept. And it's important that it's the y-intercept. A lot of students graph it in the wrong spot. That goes on the y-axis. So -1 is going to go on the y-axis. Then 2/3 is the m, and that represents the slope for the slope-intercept form. So from the point we already plotted, not from the origin, but from the point we already plotted, rise 2 and run 3 spaces to the right. That's technically enough, and we could just connect our dots, but if you do more points, rising 2 and running 3 again, going backwards, we can get more points to make a straighter line, but you don't have to. Just 2 points is good enough. You should put arrows on the end because it goes on forever. So unlike the first problems where all we had was a specific list of points, here in this equation we can plug in anything we want for x. So we know what's happening in the gaps. We could plug in a half if we wanted. It wouldn't necessarily be pretty, but we could do it. And we could plug in a million if we wanted. So we need the arrows to show it goes on forever, and we can connect the dots because there is something that's happening at each and every value.
Do we only need 2 though?
You only need 2 points, yeah. Questions on slope-intercept? The next one says y is 1. So what we're going to do is go to where y is 1. So on our y-axis, we go to 1. But that's just a point, and an equation should make a line. So what we want to do is make a line through that. So we're going to get a horizontal line. We want a line at a height that is consistently 1. Since y is our height axis, we want a line that consistently has a height of 1, or consistently has a y value of 1. That would be a horizontal line. Questions on that? This one is given to us in standard form, so we have 2 options. We could solve it for y, get y alone, and that would make it into slope-intercept form. And that's totally fine if that's your preference. It is not my preference because I feel like there's a lot of places to make mistakes when doing that. So my preference is to use the cover-up method, where I say let x equal 0, which covers up or gets rid of the x's, leaving just -2y equals 6. So then y equals what? -3. So on my y-axis, I can put a point at -3. Then I do the opposite and let y equal 0, which covers up or gets rid of all the y's, and I get 3x to 6, which means that x is what? 2. So on my x-axis, I can put a point at 2. I had the other one there at -3, and then I can connect the dots. It's the wrong screen, but that's what it was. Questions? If you chose to solve it for y, you should end up getting the exact same graph once you're done with the solving. Your equation would be y equals 3/2 x minus 3, which would give you the same exact graph. Okay, now actually for this problem, it says x equals -3. So I want to go to where x is -3, which would be on my x-axis, back at -3, and I can put a point. But I don't want just a point, I want where it is always over at a position of -3. It's going to make a vertical line. And x equals must cross the x-axis, and it crosses the x-axis at that given value. Be careful with your horizontals and verticals. Students always get them backwards, thinking that they should match the axis. So since the x-axis is the sideways axis, students want to draw this graph sideways, okay? But it has to actually touch the axis that it's naming. So it has to hit that x-axis, which makes it be vertical. Questions? All right, then we want to write an equation of a line that has the given properties. Our key for this is y equals mx plus b. What letter do we use to represent slope? M. And what letter do we use to represent the y-intercept? B. So we have everything we need and we can just plug those in their spots. Y equals 2/3 x plus 1. And that one is done. We were given the two things we need. To write an equation, we need a slope and we need an intercept. In the next one, anytime we're asked to write an equation, we're going to go to y equals mx plus b, unless you decided to look up in the book the point slope form, or you do that from another class before, and that's the way you want to do it, that's fine. It's just not the way I teach it, but that's okay to do it that way. Otherwise, we're just going to use y equals mx plus b. Slope is m, but this point is not b. This point is what? An x and a y. Okay. So now I have three things I can plug into the equation. I can plug in a 4 for y, a -1 for m, a -3 for x, and I don't know what b is, but I can solve for it. So I get 4 equals 3 plus b. Subtract 3 and I get 1 is b, but that is not my answer because the question didn't say find b or find the intercept, it said write an equation. So an equation should be my answer, and that is y equals -1x plus 1. Okay, all your answers should be in that slope-intercept form, with the slope and the intercept plugged in, and x and y as variables. Questions? In this one, we're given 2 points. So we're not given our slope or intercept. So we need to find both of those things. The first thing you have to find is slope. You had a whole section of homework. One night, every single homework problem was finding the slope between 2 points. So there weren't any specific review questions on that. This one, we're going to do that, but there weren't any that just said find slope. But since that was an entire homework assignment, I wouldn't be surprised if there were some questions in the quiz that just said find slope. Okay, so we need to make sure we know how to find the slope between 2 points. So how do I do that? How do I find slope? Subtract the y's. So I've got an x and a y, another x and a y. I'm going to do y minus y over x minus x. It doesn't matter what order you do them in. So I could do 1 minus 2, but then I also need to do 2 minus 3. Okay? So you can do first point minus second point, or second point minus first point, but you just have to be consistent. So I get 1 over 1 and I have a slope of 1. Then choose either point to represent your x and y, and use your m and do exactly what we did in the last problem. So y is 1 equals m is 1, x is 2 plus b. 1 times 2 is 2. Subtract the 2 gives -1. And my equation is y equals 1x minus 1. Plug in the m and the b, leave the x and y as variables. If you chose to use the other point instead, and still use that same m, we should get exactly the same thing. 2 equals 1 times 3 plus b. That'd be 3, subtract 3 from both sides, we still get a b value of -1. Okay, so it doesn't matter which point you use, just pick one point, whichever one you like the numbers better, and plug them in. But don't pick x from one and y from the other one. Okay, you can't mix and match. Pick one point or the other point and plug them in. Questions? Yes.
Do you have to have y on top?
Yes. For slope, it's a change in y over a change in x, so y has to go on top. write an equation of a line. So again, we're thinking y equals mx plus b. Whenever it asks us to write an equation of a line, that's our form. That passes through 4, 3. When we see the word through before a point, that's giving us our x and y. And is parallel to this line. Parallel tells us something about slope. That tells us that we want equal slopes. So what we need to know then is what is the slope of this given line. Well, it's kind of hard to tell while it's in this format, so we need to get it into y equals mx plus b so we can see what the m is. How do I get y alone?
Just by add
Add x to both sides. So that give me y equals x plus 1. So now what is the slope in that equation?
1.
1. So that's the slope I'm going to use because parallel means equal slopes. So I'm going to use the slope from that equation and I want to use the given point and plug them in. Y equals mx plus b. 1 times 4 is 4, so I would be subtracting 4 from both sides. Gives me negative 1 is b. Our final answer should use our slope and our intercept. Y equals 1x minus 1.
You just write x, right?
You could just write x, yep. Questions? Write an equation of a line. So again, y equals mx plus b. That passes through, you see the word through, that's giving us our x and y, and is perpendicular to. What does perpendicular mean about slopes? Opposite and reciprocal. Both changes, positive, negative, and flip it to this line. What's the slope in this line? 1/2. So what slope do I want to use for my perpendicular line? -2 or -2/1. Positive, negative switch. So positive 1/2 becomes negative, and reciprocal, flip it over, makes 2. So I'm going to use a slope of -2 and the given point and plug them in. 1 equals -2 times -2 plus b. Multiplying gives 4. Subtract 4 from both sides gives -3. And our final answer needs the b and the m plugged into the equation. -2x minus 3. Questions? Some of these problems on the quiz, like this last one, are going to be worth several points because there were several steps in the problem. So that means showing work is going to be really important because if something goes wrong early in the problem and your answer is totally wrong, and all I see is a totally wrong answer, you will lose like all 4 points or however much this was worth. Whereas if I can see what went wrong and that you did everything else right, you will only lose points for what you actually did wrong instead of everything. So showing work is going to be really important on this.